welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Mikhail, who has completed the online course, ROS2 Navigation in 5 days. And at the end of this online course, there is a project you can take and implement on a real robot. So that's what we're going to be seeing here today, the presentation of that project for the course. Hello, Mikhail, how are you?
Hello, I'm good. Good. How are you?
I'm great, thank you. I'm very excited to see what you've done with this project. So whenever you can, please share your screen and show us what you've done.
Yeah, sure. So I can start right now. Mm,
All right, we can see your screen now.
Yeah, great. So I have my robot already.
Mm-hmm. So right now you
Uh,
are connecting to that real robot.
yeah. So, and I will start with the demonstration of how I can command robot to go to a specific spot, and then I will explain all the moving parts of this process.
Sounds great.
Once it will be ready. So I will run two, yeah, great. To do this, I need two different launches, one with the map server and another one with the uh, localization. So to do that, I need okay, this is one and another one for path planning. And also I will start with two. So currently, localization complains about that initial pose is not set, so
Uh-huh.
robot doesn't know where it is. To do that, now let me first see where it actually is. Okay, it's on the upper left corner, and I will set initial position.
Was it facing that way? Yeah, I think it was facing the other way.
Yeah, probably.
No, don't worry. I think so because you can kind of see it there. Yeah, yeah.
Yeah,
Uh-huh.
that's better.
Oh, awesome.
So all the red dots is probable positions of that robot, and
Uh-huh.
square is the readings from the laser scan. When the robot will move, it will well, find its position more precise. So we can demonstrate it by moving it manually on that way.
I think actually twisting it is like the fastest way for AMCL to kind of
Hmm,
find it.
okay,
Oh, that should be enough,
so
I'd say.
let's see. Yeah, now it knows its position more, uh, say,
And what are those
more
bright blue
certainty.
things?
This is a local coast map, so it utilizes not only knowledge about the map that was done before, It also uses data from the laser to see the obstacles that are not on the map.
Right.
So it can plan more um, to be more aware of its current environment.
Mm-hmm.
Okay, let's order it to move to some specific position.
Oh, nice. Maybe
So
have
this command,
the robots visible so we can see it when you run it.
sure.
Maybe in case it starts going right away. Oh, they. So you did here is you sent a goal to NAV2 with a label, right?
Yeah, so
Basically.
command.
Awesome. Awesome.
So this command consists of few parts.
Uh
It's
huh.
well, name node, and then parameters file that contains a list of spots with its coordinates, and then another parameter is the name of the spot where robot is supposed to go. So let's see this spot list YAML file, and yeah. So basically, it's a parameter file with labels and
Uh
then
huh.
coordinates of the specific spot. It's x, y coordinates and orientation.
I think you know my
Uh,
next question, and is how did you get those points?
yeah, those points are done by another script. It is where it is. No, it's not file. So it's pretty simple script. It subscribes to the initial pose topic, and whenever in ROS2 we set initial drop a point as initial pose, it will record it and then write to the file. So I didn't do here any fancy processing. So, this YAML file is done manually using just data from this txt file.
Mm-hmm. So that outputs to a txt file, and then you construct the YAM out of that txt file.
Yeah, yeah, right.
Awesome.
So let's maybe see contents of the path planning. What do we have here? Where it is? Yeah. So this is a node that are responsible for processing that comment that I showed earlier. It has action client that sends a navigation goal to navigator post topic that is processed by navigation. And it's also interesting here is parameters. So it has two parameters. It's a spot name parameter that
Mm-hmm.
comes from command line directly, and another set of parameters. It's a list of um, a list of points, and those parameters are loaded automatically. So you just need to declare them properly and properly structure the YAML file. Um, yeah, so it has send goal methods. And, it basically we set coordinates on where to go and which orientation we need to,
Mm-hmm.
and yeah, that's it basically. So since it's action clients, we have also callbacks for response for that is processed immediately whenever we submit goal, then result when the goal is done, and feedback for printing the feedback while the robot is going.
Mm-hmm.
Yeah. Mm, what else I can show? Um,
Could I
mhm,
ask you? So could we actually see this saving of a spot? I saw that you have a couple spots already made. Could we
mhm.
maybe see that process, is that is because that's is that in a service server, or how do you obtain those points from that initial point? Can we see that a demo of how you do that?
Yeah, sure. To do that, we need yeah,
Yeah, yeah.
ah,
Do we see that spot recorder in action?
like this project localization. Yeah. Mhm. Should I apply? No.
Maybe with if you start before you do look the name of the executable, just press tab and it should show what's in there. There you go.
Mm. Yeah, I'm just not sure which version to run because I have two versions. One
Oh
that
yeah, so maybe
takes
you
from
have
ROS.
to. Is the setup.py in that package? Does it include both executables? Oh, so
It's version two.
oh, it's version 2. Nice.
Great. So another one, it records spots from the current position of the robot.
Mm-hmm.
So I did V2 to as it's instructed in the course. Anyway, let's jump to ROS and we can um, estimate the pose and well, yeah. So
I'm
we
okay
can
with that.
see
Yeah.
that, and if we check the txt file, where it actually writes it.
I see.
Yeah. So this is the point that's
Okay, and correct me if I'm wrong. At this point, you then manually take these coordinates and put it into a YAM file.
yeah, those two x, y, and then orientation
Okay.
on again. Yeah.
Okay, I see.
So this
All
is
right.
the process.
Sorry, I've been interrupting you. I just figured it would be nicer if I could ask the questions as I go. Is this basic? But basically, we've covered everything, right? Unless you
Yeah,
want
I
to
also
say something else.
can. Yeah, I also can show what's actually in the launch files. So which nodes do we run here? So project localization. Yeah, so it's a map server node that takes map that was created previously, and it's an MCL node that's responsible for localization and lifecycle manager to manage those two nodes and run them not separately, but in a manageable manner. For a path planning, things, it's navigation controller, navigation planner, behaviors, BT navigator, and also lifecycle manager to run those four nodes well in a manageable manner. Yeah, that's pretty simple.
Mm-hmm. Mm-hmm.
Mm. Yeah, I think that's it.
All right. Awesome. Great. Great. Let me move back here to so I can see yourself a little better. There we go. Um, Great. Congratulations, Mikhail. Very nice presentation.
Thank you.
It
Thank you.
was, let me tell you a couple of things I enjoyed. I really liked seeing the use of parameters already in ROS2 to load, for example, the path of the txt file and then even the labels, right? So you did declare parameters for each one. So then you can take those in really simply and use them. So I have a couple of questions. Mm, so correct me if I'm wrong, but you mentioned, I might be misremembering, but you mentioned that the usage of the initial pose is required for to get those points by the instructions of the project.
Yeah, it says that you need to get those points from
From
initial
the
pose
topic initial
topic
post.
from
Oh,
topic.
okay. That's good that I know that, because obviously my question is, because I'm starting to see the little bit of a, not an issue, but obviously there's another way to obtain that pose, which is through the AMCL pose that is being published once you start. That's your version 1, right?
Yeah, that's
Okay, so then in my opinion, I'm sorry, but I think there's pros and cons between both of them,
mhm,
using either the initial post and the or the AMCL post. But I'm starting to lean a little bit more towards your version 1. So how you thought about it in the first way, and let me tell you why. So uh, the initial post is really helpful because all you need to do, right, is have the map and just basically click when you have the server running, click the initial post so it would record that and just put it up. Instead of actually having to move the robot to that location,
mhm,
which is the first version is move the robot, make sure it's localized basically, so that's an extra step. But then you move the robot and record the position. Now I'm starting to like that more than your first version because I'm thinking of application of making it more and more automatized, right? The
mhm,
program.
yeah,
So the I'm thinking of an application with the first server you did of, the robot moving around for a bit by itself, and based on maybe a error or takes a picture and sees that something's wrong, you can use that server in order to sort of record those spots. So I was curious about that, and um, but I wanted to mention these two ways, and I'm glad you tried it both ways to see the
mhm,
pros and cons of that. And on that note of on making more things more automatic, let's say. Um, so my suggestion for an improvement would be to, so when you record the spot, right, you basically dump the output into the txt file, right?
mhm,
So this isn't have to do with robotics. It's a little bit more with Python and dealing with txt files. What you could do is actually have a skeleton of already the YAML file, right? So it would have ROS parameters and then the name of your node, and then using sed or something like that, well, whatever in Python, substituting those already formatted values into the YAML file, so you don't have to copy and paste and go over. And for
yeah, yeah,
example, we could have seen this new point, send a command to that point, and we would have seen that movement. Of course, I'm not gonna make you copy and paste all those to see that. So that would be my suggestion on what to improve. But other than that, Mikhail, I thought it was a really nice project, and it shows that you took your time with it because of how easily and how the muscle memory of this terminal
mhm,
opening and launching really speaks a lot, and that's one of the reasons we do this. To obtain a certificate, we want to verify that these things happen. So I want to congratulate you again, Mikhail, for a very nice job.
yeah. Thank you, thank you.
All right, and that's it for us, guys. So let me switch back to my screen. And yeah, this is what you can do when you take one of our courses. What Mikhail did here is to present the final project in order to obtain a certificate from us from a lot of our online courses. So I invite everyone to do what Mikhail did here and present what you've learned in our courses. Uh, uh, that's it for us, guys, for today. So see you guys next time for the next presentation, and bye bye.